Yep, it's yet another workbench narration. Good grief, I've got junk everywhere. I have got to clean this place up a little bit. Got way too much stuff, but it's strictly amateursville here at Evening Stars Labs because I don't know anything about making videos. This is the first video of any kind that I've ever produced. Okay, well, when I was a kid, I played with my dad's 8mm video camera until he told me to stop because he got me plenty of toys of my own I could break. He just didn't want me breaking his. So I break my own toys now, and it's a lot more fun because I don't get in trouble for it. I've got this $15 microscope camera here. I got to show you this thing. Right now, it's about 11 inches above the surface it's observing, and it shows pretty good detail. It says it's 1,000 power, and it isn't. It's maybe 250 power. And I can get a lot closer and a lot more detail out of it. It color corrects incorrectly, but, well, yeah, what are you going to do for 15 bucks? I'm pretty happy with that. And then I've got this Logitech Quick Connect webcam. It's about, I don't know what, 10 years old maybe. And I'm going to use that just for showing instrument readings and things that are out to the side of the workbench that we need to look at. But it does the job for that. And I'm using the best thing here is my iPhone 7 camera, which I'm using to photograph, to capture the work area. And it's really good. But when you get it this close to a subject, use a level to focus your smartphone's camera, because if it's not level, let me show you, you'll get distortion along the edges. And, this is another way you can tell this is going to be a different kind of webcast. I've got this metric side of the cutting mat up. Most people put up the inches side because, well, they're Americans. And, it's like Arduino versus Evil, AVE said, inches got this country to the moon. Except, what have we done since then? I'm going to use metric. I'm going to try something different just to see if we can make any better progress. And, I spent $100 on an Audio-Technica AT2020 microphone. Now, it's not up to the Booth Junkie's standards. I'll put a link to him down in the doobly-doo. The technical name for the area below the video here, given by Arduino versus Evil, named it precisely. I'm really grateful to him for that. But this microphone gives really good sound. Booth Junkie has reviewed it, and so far it's doing what I need it to do. And I got a flashlight hanging here to light up the microscope area. Okay, let's get back to what we really want to talk about. But before we do that, I got to clean up my space here. Sorry about that. That might be useful later. Way too much stuff. Use later. And my latest disappointment from Microsoft. The rubber around this wheel, this mouse is less than a year old, and the rubber around this wheel has dissolved into a gooey mess. It's getting all over my fingers and sticking, and it was just horrible, and the wheel barely turns now. Less than a year old, and it's a useless piece of junk now. You can't find a screw to take it apart and clean it out. There's not one. And I could use extraordinary force to disassemble it, but no. For Microsoft hardware, it's just not worth it to me because I just don't think there are any. How many Surface Pros have they bricked with their updates recently? I mean, well, I don't want to rant about Microsoft. This is what I want to talk about. The Urseri UMO2 Digital multimeter. Okay, how boring can it be? Another multimeter video. But I saw this thing on Amazon for $8, $7.99. And it's an auto-ranging digital multimeter that performs all sorts of neat functions. And I thought, well, I got to have it. I got to see what it does. Now, by auto-ranging, this Old Faithful I've had for about 15 years in my toolbox. The day I got the Urseri, this thing died. This is not auto-ranging, excuse me. By auto-ranging, this thing automatically senses the range of the component that you're testing. With this, a non-auto-ranging multimeter, you have to select the range that you want to test. You don't have to do that with this. In that way, it's like the Fluke 87V, Old Faithful. I trust this thing. I get it recalibrated every, 3 or 4 years maybe. It's been a couple years since I've had it calibrated. But I trust it. I don't know if I'm going to trust this thing. We're going to find out. So let's take a look at it. I promise I will never, ever do a real unboxing video. I hate those things. I just wanted to show you how this thing arrived. It comes in this little nylon case. I wouldn't say it's ballistic nylon. It's not. It'll scuff. It'll get hanging threads. It'll tear, but it offers fair protection. It's not flimsy. And, it comes with a thermocouple. And the leads are not silicone rubber. They're plastic. We'll find out how they perform. And it's got this rubberized, I don't know what kind of plastic it is. I'm not a mechanical engineer like AVE, and I can't sniff it and tell you its exact chemical composition. If you want to know, ask him. But it seems fairly robust and like it'll give adequate protection when you throw it in your toolbox. So let's compare this to the Fluke and see how it measures up. For that, we're going to use this Chinesium voltage reference. I don't know if I trust this. If you look in the back, at 2.5 volts, somebody wrote here that it tests at 2.5.0003 volts. At 5 volts, it tests out at 5.00047 volts, and so on. As I understand, every one of these has the same values handwritten on the back. The only reason I think I can trust it at all is because of what my Fluke reports. So let's take a look and see what the Fluke says this thing actually does. We'll try it at 2.5 volts. And the Fluke reports 2.5 volts. Good enough so far. At 5 volts, it reports 5 volts. 7.5 volts, 7.5 volts. And at 10 volts, Fluke reports 10 volts. So, for right now, we can trust this thing. Let's find out what the Urseri reports. Attention to detail. That's important to me. And they did it when they packaged this thing. So we'll find out if that carried over to the manufacturing process. Find out how well this is calibrated. So we switch on DC volts, beep, it's ready. And turn on the voltage reference to 2.5 volts. And the Urseri reports 2.5 volts. And let's try it at 5 volts. The Ursaring reports 5.002 volts. 0.002 of a volt difference between the Ursaring and the Fluke. I don't care. 7.5 volts, reports 7.5 volts. 10 volts, it reports 10 volts. That's good enough for me. I got no complaints about that. So, let's see about resistance. Now, got here a 1 kilo ohm resistor. The only reason I know this is that's not it. Is it? Yeah, might be. We'll find out exactly what it is. Yep, this is the 1 kilo ohm resistor. See, I don't have the colors memorized like Big Clive does. He's an electrical engineer. I'm not. I'm a sysadmin. I administer networks, manage, computers, things like that. I don't know anything about electrical engineering. He's the expert. When I want to know the value of a resistor, I'll test it with my multimeter. So, Fluke says that's 1001 ohms. Let's find out. What the Ursaring says. The Ursaring reports it. Oops. Maybe if I held that steady, it would help. 998 ohms. Okay, so that is a 3 ohm difference in measurement between the Ursaring and the Fluke. Yeah, I don't care. That's pretty good. And it measures, like I said, capacitance and diodes and so forth. It's got this non-contact voltage measurement. Let me show you how that works. Let's see if I got it. Yeah, I got an AC line over here. We turn it on. I'm going to hold this up to the camera so maybe we can hear it. It's got a pretty quiet beep. So if I bring this electrical cord within range of the non-contact voltage sensor here, it lights up and it starts to beep. Can you hear it beeping there? Now, non-contact voltage measurements may be false alarms. If it tells you there's a voltage, there might not be one, because these things are sensitive to magnetic fields and so forth, and induction that might be built up inside the meter. And when it tells you there's a voltage there might not be one. It might not tell you when there actually is a voltage present. So I'm never going to trust non-contact voltage measurements. When I want to know if there's a voltage present, I'll use a lead and an actual physical measurement. If I can't get my hand in there to test it, I'm not putting my hand in it because, well, I started my career in stage lighting 40 years ago, and the thing I learned about electricity then, aside from the fact that staring into stage lights to focus them would give you astigmatism, is that 440 volts gives one heck of a kick. And I learned that lesson so well that, well, 40 years later, it's been, 3 or 4 weeks since I got shocked. Oh, okay, never mind. Anyway, I'm pretty impressed with this thing. Let's measure some current and see how it is on that. I've got the power supply turned on, and it's set to deliver 5 volts constant, and I think a maximum of 1 amp. I want to turn off the current protection because we're going to violate the current. This is one of those cheap Chinese loads. It's hard to adjust precisely, but you know, it works fairly well for what I need it to do. You can tell it's running by when the fan turns on, and we'll find out what kind of load it's set to draw right now. Oops. Keep the leads connected. So right now it's drawing 0.399 amps. Let's leave it at that. It's almost 400 milliamps, 399 milliamps. I trust the power supply. That thing's been calibrated and it's within just, 1 or 2% on most of its settings. So let's find out. We'll start with 10 amps and find out what kind of current this thing thinks it's actually being produced here. So I'm gonna, now multimeters don't actually measure current. What they measure is the voltage drop across a resistor that's inside the multimeter, and they use Ohm's law to determine exactly what the current is that's going through that circuit. And, that kind of reading is good enough. So let's find out. On. And power supply says we're drawing 400 milliamps, 399 milliamps. The meter is reporting 402 milliamps. A 3 or 4 milliamp difference. I don't care. That's good enough for me. I'm really impressed with this thing. I'm not sure how long it'll last, what kind of longevity it'll have. It might not last at all. But at $8, it's a disposable multimeter. So, yeah, it's probably worth it if it won't kill you. So, what I want to do is I want to take it apart and see how it's fused. Now, the Fluke has 2 fuses in it. It's got a 440 milliamp fuse for most of the circuitry in it, and an 11 amp fuse for measuring high currents. Let's find out if this thing has any fuses in it at all. Screwdriver here. Looks to be ABS plastic. I don't know. Ask AVE. Like I said, he's the expert. Got 3 AA batteries, or AAA batteries by Goldman, some off-brand. If I buy batteries, I'm going to buy the cheapest ones there are. I'm not going to spend $1 million on Duracells or anything like that, because the cheap batteries, they do the job. And in the long run, I think it's more cost effective to buy them instead of, paying a premium price for a name brand battery. Except when it comes to lithium cells. Lithium cells, I want Samsungs. Because like the 18650s, I can trust them to deliver the voltage and the current that I need when I'm playing around with IoT circuits. Arduinos and the ESP8232s and 38082s. Yeah. The little microcontrollers, those things can be fairly sensitive. So, okay, we've got 2 fuses. And one is 5.7. The other. Oops. Okay. F10 amp at 700 volts. And this one doesn't say. We can look that up. Oh, yeah, it does. Need a magnifying glass to read it. I've got old man eyes, and even my glasses don't help sometimes. So this says, don't know if you can see that there, 600 milliamps at 700 volts. So it's got protection for the internal components and for current measurements. It's the shunt resistor right there that it uses for measuring current. Measures the voltage drop across that little resistor. It looks like it's just a wire, but even this has a certain amount of resistance. It's got very little resistance and sucks up a lot of power, produce heat, but that's how multimeters measure current. So let's put this back together. I guess I got no complaints with this thing. It's fused. It's got 2 fuses. A lot of multimeters have only one. And it's fairly accurate. So for $8, a disposable multimeter, go for it. A lot of times you need 2 multimeters, one for measuring voltage and the other for measuring current when you're testing circuits. I've run into that a lot, and Old Faithful just bit the dust. I think it was really disappointed when I got this thing. I thought that it was going to be replaced. I wasn't planning on it, but, well, it just decided it wasn't going to measure anything anymore. So, time to put that out to pasture and replace it with this. I'm going to get another one of these and give it to my grandkid so he can destroy that one instead of playing with my Fluke. He's tried to blow it up once already, and I don't want him to actually do that again. Fortunately, all I had to replace was a fuse in it. But he takes after his granddad. He's really good at destroying things. Yeah, he's going to be dangerous when he grows up. Anyway, I hope you got something out of this. I got a little practice in using OBS Studio and making videos and so forth, and that's the only thing I really wanted to use this recording for. If you didn't get anything out of it, well, let me tell you, there are a lot of really good channels and better people to watch. If you're interested in this kind of topic, go watch AVE. Go watch Big Clive. Go watch, the Booth Junkie. They know what they're talking about. And I'm not making any money off of this. I bought this Urseri multimeter off Amazon. And I'm just here to learn and to have fun. Oh, and if I'm wrong about something, please tell me in the comments, because, well, being wrong is the best time to learn. So if you want to play, come back. And for gosh sakes, have fun.